I want to show that the sequence is monotonic and bounded. So first, let's start off with the sequence a sub n equals n over 2 to the n plus 2. A sequence is monotonic if it increases or decreases. So in other words, if the sequence is increasing, you have a sub n is less than or equal to a sub n plus 1, and decreasing if a sub n is greater than or equal to a sub n plus 1. So if I divide both sides by a sub n, that means the ratio has to be greater than or equal to 1 or less than or equal to 1. And this makes sense. Okay, now let's look at the ratio here for our sequence. For a sub n plus 1, we want to replace n with n plus 1. So when I look at this, I'm going to divide the top and the bottom, which is really the same thing as taking the top and multiplying by the reciprocal of the bottom. Okay, so I have 2 to the n plus 3, 2 to the n plus 2. Those are going to cancel. I'm going to be left with 2 in the denominator. And so I can simplify this further, or actually rewrite this rather, as n plus 1 over 2n. Now, this doesn't tell us if it's increasing or decreasing. So to convince you, I'm going to graph this. So pretend we have y equals x plus 1 and y equals 2x. Which one of these is bigger? Well, for y equals 2x, we get this. For y equals x plus 1, we get this, but the slope is narrower. So it has to connect at 1, 2. Okay. So pretend it's straight. So clearly, the y equals 2x is greater, except at x equals 1, and I guess x less than or equal to 1. Okay, so when x is 1, they're equal. When x is 2, 2x is greater. Okay, and it turns out x greater than or equal to 2 is greater. 2x is greater than x plus 1. And because we have a sequence here, the sequence defined for n equals 1, 2, 3, etc. So we're only interested in those numbers, which clearly, as we've shown here, 2x, or rather 2n, is greater than or equal to n plus 1. So that means that the denominator is bigger, and therefore the ratio is less than or equal to 1, which means the sequence is decreasing. So therefore it is monotonic. Now we want to show that it's bounded. Okay, so I have n over 2 to the n plus 2. It's going to be bounded above because the sequence is decreasing. So the first term should always be, so if it's decreasing, then the first term is greater than or equal to the second term, greater than or equal to the third term, etc. So clearly the upper bound is the first term, which I plug in n equals 1 and get 1/8. Now I know that the limit here, well, I know that this is always going to be greater than or equal to 0 because I have n that is positive, n equals 1, 2, 3, etc. And the limit here, if I take the limit, I technically need to do L'Hopital's rule, but if you have a linear function over an exponential, the exponential is a lot bigger. So we know that this is going to go to 0. So this is going to be bounded below by 0 because it cannot go below 0 because that means it'll have to be negative. So what we're saying is that 0 is the lower bound, and it'll never reach 0. It'll only get closer and closer to it, and then 1/8 is the upper bound. So this is bounded, and it is monotonic. Now let's look at another one. We have a sub n equals 2/3 to the n. In order to show that it's monotonic, we have to show that it's either increasing or decreasing. And that comes down to finding the ratio. So that'd be 2/3 to the n plus 1 over 2/3 to the n, which simplifies to 2/3. The ratio is less than 1. Therefore, the sequence is decreasing. And a sub n is monotonic. Now for bounded, we know that 2/3 to the n is decreasing. Therefore, the first term should always be the greatest. The first term is 2/3. So this should be greater than or equal to. And we know that the limit here, this is a exponential, goes down like that. So clearly it's going to reach 0 eventually. Okay, so it's bounded below by 0 and bounded above by 2/3. Okay, now a sub n is equal to cosine of n over n. We know with cosine, it always jumps between positive and negative. So it's, it decreases at some intervals and then it increases again. So the sequence, increases, decreases, it goes back and forth. So it's not a nice strictly decreasing or increasing situation. So this is not going to be monotonic because of that. But it is bounded because we know that cosine is between -1 and 1. And if I divide everything by n, I get this. Think of 1 over n as a sequence, right? So if I have a sequence as 1 over n, we know that's going to be 1, 1/2, etc. The biggest term is going to be 1. Okay? The smallest term is going to be 0. Similarly, if I have -1 over n, we know that's -1, -1/2, etc. The smallest is going to be is -1. So what I just found here is that our sequence is bounded above by 1 and bounded below by -1.